Morning to all of you. In previous session, we have seen one example related to Z transform. We have plotted it ROC. In today's session, we'll discuss one more example of Z transform. So here, again, you have to determine the Z transform of the signal x of n is equals to minus alpha to the power n u of minus n minus 1. Okay. So again, you have to determine the Z transform of the given signal x of n. So the given signal x of n is given it is x of n is equals to minus alpha to the power n u of minus n minus 1, right? As we know that this unit step signal u of n, okay, is one of the elementary discrete time signal, and u of n will be 1 for n greater than or equals to 0, and it is 0 for negative values of n, right? But when will be the parameter passed to u will be negative. So basically, when we'll be substituting here the values of n as positive, right? So if I'm substituting n is equals to 1 here, right? Just for example, if I'm substituting n is equals to 0, right? So if I'm substituting n is equals to 0, so this will be u of minus 1, right? So u of minus 1 will be 0, correct? If I'm substituting n is equals to 1, so it will be minus 1 minus 1, so it will be u of minus 2. So again, u of minus 2 will be 0, right? If I'm substituting n is equals to 2, so it will be minus 2 minus 1, it will be u of minus 3, so u of minus 3 will be again 0. So that means this signal will be 0, okay, for n greater than or equals to 0. That means if I am substituting the values of n greater than or equals to 0, then this complete signal will be 0. Why? Because this u of minus n minus 1 will be 0 for n greater than or equals to 0. And if I am substituting negative values of n, that means if I am substituting n is equals to minus 1, so minus minus plus would be there, so 1 minus 1 will be 0, u of 0 is 1. If I am substituting minus 2, so minus minus 2 will be plus 2, so 2 minus 1 will be 1, u of 1 will be 1. So for negative values of n, this value will be 1. Okay, so that means this x of n will only exist for negative values of n. Okay, that means for n less than 0. So for n less than 0, the signal value will be alpha to the power n minus alpha to the power n. Okay, so again, the Z transform of x of n is given as capital X of Z is equals to summation n is equals to minus infinity to infinity x of n into z to the power minus n. Okay, so this is the standard formula. So here in place of x of n, you can substitute the given signal value, that is minus alpha to the power n u of minus n minus 1. So you can substitute minus alpha to the power n u of minus n minus 1 into z to the power minus n will be as it is. Okay, so again, you can replace this u of minus n minus 1 by modifying the limits of this summation variable. Instead of taking it from minus infinity to infinity, as this u of minus n minus 1 will be 1 for only negative values of n. So instead of minus infinity to infinity, it will be from minus infinity to minus 1. Okay, only for negative values of n this signal will exist. So you can modify this limit of summation as n is equals to minus infinity to minus 1 minus alpha to the power n z to the power minus n. Okay, so this is how you can modify this limit, right? So all the positive values of n are eliminated from this summation variable. Okay, because for n greater than or equals to 0, this u of minus n minus 1 will be 0, right? So I will rewrite this equation here. So x of z, what we have now, x of z is equals to summation minus infinity to minus 1, n is equals to minus infinity to minus 1 minus alpha to the power n and z to the power minus n. Okay, we have seen the infinite geometric series and infinite geometric series as, that is, in previous examples we have taken it as n is equals to 0 to infinity a to the power n. So where this will be 1 plus a square and so on, right? Which which is equals to we are taking it as what, 1 upon 1 minus a if mod a is less than 1. But here the summation limits are minus infinity to minus 1. Okay. So it should start from 0 to infinity, or at least 1 to infinity should be there, right? So therefore you can take this minus sign common, and or you can say that in place of n, or you can say that in place of n you can substitute value, just for example minus m. Okay, so what you will get, capital X of z is equals to, in place of n I am substituting minus n, but this minus sign I will send inside this summation limits. Okay, so this minus will be plus, so instead of writing infinity to 1 it should be 1 to infinity, right? So I can write here m is equals to, or I will initially write minus m is equals to minus infinity to minus 1, right, minus alpha raised to the power minus m z to the power n. Okay, so here I can say that x of z is equals to, if I am sending this minus sign inside the summation limit, so instead of calling it as infinity to 1 it should be 1 to infinity, because lower value to higher value should be there. Okay, so it will be m is equals to, so m is equals to 1 to infinity will be there. So even I can take this minus sign outside the summation. Okay, so here it will be alpha, and I can take m common from here, so it will be alpha inverse z raised to the power m, right? So this is the final simplified z transform equation. M is equals to 1 to infinity alpha inverse z raised to the power m. Okay, so if you compare this geometric series with this one, okay, so only thing common here is that uncommon here is that it is starting from 0 but it is starting from 1. So if I am just modifying this geometric series as, instead of taking it as n is equals to 0 to infinity, for taking it as 1 to infinity a to the power n. Okay, because here summation limit are from 1 to infinity, right? So if I'm taking it as 1 to infinity a to the power n, so the equation will be a plus a square, right, plus a cube plus and so on, right? So again I can take a common from here. So if I'm taking a common, so in bracket it will be 1 plus a square plus a cube plus and so on, right? Oh, sorry, a is remained, I think. Okay, should be a square, right, plus a cube and so on. So 1 plus a square plus a cube plus and so on. So if you replace this bracket value, because 1 plus a square can be replaced with 1 upon 1 plus, oh sorry, 1 upon 1 minus a. So in place of this bracket we can substitute 1 upon 1 minus a. Okay, that means it is simply a upon 1 minus a if what, mod a is less than 1. Okay, so that means if summation limits are 1 to infinity, so you can use this form, that is a upon 1 minus a. So that means it will be alpha inverse z upon 1 minus alpha inverse z, right? So again I will rewrite this equation, that is x of z equals to what we have here is minus summation m is equals to 1 to infinity, and it is alpha inverse z whole raised to the power m. So this can be replaced with the simplified form, that is a upon 1 minus a, right? So you can write here this minus sign will be as it is, in place of a this value is there, so alpha inverse z upon 1 minus alpha inverse z, provided this alpha inverse z should be less than 1. Okay, again I can send this alpha inverse on the right hand side. Okay, so this x of z, final x of z will be minus alpha inverse z upon 1 minus alpha inverse z. This is the required set transform. Okay, And as per this equation, if I'm sending alpha inverse to right hand side, so it will be 1 upon alpha inverse. If I'm taking in numerator, so it will be alpha simply. So mod z will be less than alpha. So this will be the ROC. What will be the ROC? So as per this equation, you can write mod z is less than alpha. Will be the ROC. Correct. So again here you can see that if I'm simply substituting the value of z is equals to alpha, if I'm substituting z is equals to alpha, so it is 1 upon alpha into alpha, so alpha will cancel, so it will be 1, 1 minus 1 will be 0, and 1 upon or alpha inverse z upon, you can say it will be again 1 upon 0 will be infinity. So you cannot take z is equals to alpha as the ROC value or inside the region of convergence, right? But again the region of convergence or the ROC values of z are restricted by this condition, okay, or you can say this condition that we are taking here in the geometric series, okay, which we are writing in the simplified form. Okay, so the ROC condition is restricted by this condition here. Okay, so again, if we want to plot this ROC, so again we'll be plotting the ROC. We'll be taking the real values of z on x-axis, imaginary values of z on y-axis. Okay, and again we'll be plotting a circle with radius alpha, right? So a circle with radius alpha will be drawn, and as ROC the values of z are less than alpha. That means the ROC will be this, sorry, this interior part of circle, right? So this will be the ROC, right? So it should be the inside circle, interior to the circle. This alpha will not be included in the ROC, right? This alpha will not be included in ROC, and if ROC is interior to circle, then signal is anti-causal, or it is also called as left-sided signal. Okay, is an anti-causal or left-sided signal, right? So left-sided means again the values of signal are present only on the left-hand side of the origin. Okay, values will not be present on the right side of the origin. So therefore it is called as left-sided signal, or it is also referred as anti-causal signal. I have seen two classification in previous session as causal and non-causal, right? So there is third terminology which is called as anti-causal. Okay, so there are three different categories, right? So first one is causal, second one is non-causal, and third one is anti-causal. Okay, in case of non-causal signal, there may be some part of causal signal present, right? So that means cause of how you are specific defining the non-causal signal or non-causal system whose output depends only on the or output depends on future input sample as well. It may also depend on current input sample and the past input sample, but it should also depend on the future input sample in case of non-causal. But in case of anti-causal, it is exactly opposite of the causal signal, right? So these three different terminologies are there, that is causal, non-causal and anti-causal. Right? So this is how again here the difference that we have seen in the previous example. The limits was from 0 to infinity, okay, but here we have modified it as 1 to infinity because the given signal uh, is dependent on the unit step signal, which exists only for negative values of n, okay, in this case because it is u of minus n minus 1. So therefore the summation limits here are 1 to infinity, and because of that we have used this geometric series form for 1 to infinity, that is a upon 1 minus a. So according to this we have written this simplified version of the given. So we get this equation of Z transform, and as per the condition we get ROC not Z, the values of Z less than alpha. So we have plotted this ROC. This ROC is interior to circle, correct? So when it is interior to circle, that means the signal is anti-causal, or it is also called as left sided signal. So in next session we will again discuss one more example on Z transform. Thank you for joining this session.